What if I told you you haven't used your printer to its full capabilities? Want to stretch those capabilities to do something like this? Or maybe this? Have a 3D print mimic the curved snap of a snap bracelet, or simply interested in leveling up your 3D printing skills? This is 4D printing. Join me as we explore the world of 4D printing and show you how you can do this yourself. To begin, what is 4D printing and what is it inspired by? Like many scientific explorations, 4D printing was inspired by nature, an attempt to not only understand the processes, but also replicate them, like the snap of a Venus flytrap, closing of a mimosa plant, or even the explosion of a pine cone during dry weather. 4D printing mimics this shape change in response to environmental stimuli. Through the 3D printing process, you too can introduce this dynamic change in otherwise boring prints. Now, many complex CAD and simulation software may not be accessible to everyone, but do not fret. I will show you how you can maximize the free, open source, and accessible softwares to create the same outcomes that are currently being researched in labs all over the world. So what are some examples of 4D prints? And how do they work exactly? A simple example of a 4D print could be the color-changing PLA filament that you can easily buy off the shelf, ranging from glow-in-the-dark materials that soak up the light and glow in the dark, to those that change from one color to another in higher temperatures. A better but more complex example would be shape change due to the printing method and settings. Now, this doesn't mean you have to use a specialized material, but rather you just need to take a little more care in your settings. And that is what we'll be touching on today. The key to this is the nature of PLA. PLA is one of the many shape memory polymers or plastics that is easily available. Like memory foam, it can be stretched or compressed while still remembering its shape. We can see this effect here. We can heat up this thin print and then scrunch it up while it's still malleable and hot. Then we let it cool, and now it's rigid and stays scrunched up. However, if we want to get it back to its original shape, all we have to do is reheat it and it'll simply pop back into place. Isn't that amazing? Now picture this. As you print, you're actually stretching the material very much like stretching a rubber band. And as it cools, the plastic actually freezes in place and keeps that built-up tension over time. After repeating this process during printing, you can release all that tension simply by putting it in hot water, and that's what we demonstrated earlier. You can then see it spring into a curved shape. We and others have tested various printers that you can get this effect on, such as the Ultimaker, Prusa, Raise 3D, as well as the more accessible Bamboo Labs. Now, we know that not everyone has these exact printers, but we would love to hear what printers you're working with and see your results. So do let us know in the comments below what you are testing this out with. On to what you will need to start experimenting with this technique on your own. First of all, of course, you will need a 3D printer. And as mentioned earlier, not just any 3D printer. Here are some of the printers that we have personally tested this effect on, apart from the ones that we have shared above and the ones that have been tested in various labs around the world. If you do not have any of these printers, do not worry, you can always use these techniques and see the effect and how greatly you can push your printer and these processes. As mentioned earlier, we will use PLA, which is also very easy to get off the shelf. You can achieve this effect with hot water as well, so you don't need to think too much about a special material or a special process. However, do note that PLA has a variety of versions, from the matte PLA to the silk versions, or even the shiny variants, even PLA infused with wood fibers or carbon fiber, all of which have various changes to the microscopic structure of the material and thus affecting the curling. So for today, we'll just work with basic PLA or PLA Plus or PLA Pro. But for those who are located in the sunny island of Singapore, where we're hailing from, a quick shout out to Tab PLA, which I personally tested and works on the Bamboo Labs printer. Finally, for the slicer. For those who really want the full works and have ultimate control over your prints, use Cura. But for this program, we'll be just keeping it simple and using the Bamboo Labs P1S printer and the corresponding Bamboo Studio for our slicing. With that out of the way, let's get started. Even without 3D modeling or CAD software, you can achieve this effect by simply using the primitives that are built into the Bamboo Studio slicer. For now, let's just start out with two cube primitives by right-clicking on the build platform and selecting primitives, then the cube one. For those who have caught on, this print is actually made up of two layers. One layer that shrinks, and one that shrinks a bit, but not as much. This is actually how you get the warping. So onto the dimensions. Let's make both our layers actually 5 centimeters by 5 centimeters. Then let's make our bottom layer 0.4 millimeters thick and our top layer 0.6 millimeters thick. We then want to assemble the pieces together like so. Okay, now on to the really important part, which are the settings. So these settings are, a bit more complicated maybe, or the things you might change more than a usual print. So we'll just leave the settings up here for your reference, or you can pause the video at this point. With that done, we can preview the slice model by simply clicking preview and seeing how the settings actually affect the print. As you see, the bottom of the model is like your typical print with alternating crisscrossing layers. But for the top layer, you can see them all print in one single direction. And that's what allows the print to shrink in that particular direction. All we have to do now is print, and that shouldn't take too long at all. Now with that done, we have a few samples here just in case. You can never be too sure with any of these experiments. So you can see them here with different dimensions and different thicknesses. You can see the B is actually the base layer of both from 0.02 millimeters thick all the way to 0.06. And we then have 3 different colors of 3 different PLA materials. So, if you haven't really followed along in slicing of the primitive or adjusting the settings, do not worry, you can also find the link to the model below. So let's see what happens when we put all these samples in hot water one by one. Look at them curl up. You can see the shrinking right here, and actually it's really fast. Now, the dimensions here are just a reference of, what you can experiment with. And actually you can go larger, smaller, and see the results with different effects. Here we have a few examples of the different curves you can get from the samples we printed already, just by simply varying the top and bottom thicknesses. But what if each layer were opposing each other like we see here? So by opposing, what I mean is that one is printed in one direction and the other one is printed perpendicular to the other one. So what happens then? What we actually end up creating is something called a bistable structure, where when it's immersed in hot water, it changes into one of 2 possible curves. And actually it's really interesting. You can check it out here. As I immerse it in hot water, it curls up into one curve. And if I gently just press it, it will get into its second curve shape. With this simple concept in mind, here are some examples of what you can do with this slicing technique. Using the same concept, here's a replica of the flower by TU Delft that you can print flat, whose petals not only fold up, but fold up in a specific sequence in hot water. And guess what? This is real time. You can make the leaves to go with the flowers you make to mimic the curve of natural leaves, all starting out as a flat print but change shape with heat. Imagine bouquets of these folding flowers that don't just last a day or two, but entire months or even years. You can even create these petals that are parts of the flowers and scatter them all over the place. For those interested in using Cura instead, and want more control over this morphing messiness, check out the video above for a complete walkthrough. Link will also be in the description below. Finally, for those who have stayed up to this point, here are some of the places and some of the links that you can find more information about these shape-changing prints. For example, the flower was recreated simply from this image by the Amir Zadpoor Lab in TU Delft. For those budding or curious engineers and designers who are out there wanting to know more about this process and the various applications of this shape change, you can look up the impact and research in architecture, design, engineering from all the labs listed here. Thank you for watching. We hope that you can level up your 3D printing game very much like we have with these shape-changing prints. We love to hear what you are up to with these shape-changing techniques and tricks. So do share with us your questions, comments, and maybe some of your projects that you have embarked on with this technique in the comments below. Remember to like and subscribe as we create more maker tips and tricks.